Hello students, this is Dilip Udhani, Assistant Professor at LJ Institute of Engineering and Technology. Today I will teach you Euler Cauchy differential equation. An equation of the form that is E0 x raised to n, nth derivative of y with respect to x plus a1 into x raised to n minus 1 into n minus 1 derivative of y with respect to x plus dash 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 plus a n y equals to q of x, where a0, a1 up to an are constant is called Euler Cauchy equation. To solve this type of differential equation, we suppose that x equals to e raised to z. Now taking logarithm both side, we will be having z equals to log x. And if we will put down x equals to e raised to z and simplify this equation, right? Okay, so during that process we will suppose x dy by dx equals to capital dy, where this capital D, that is d by dz, and x square d square y by dx square, that will become d into bracket d minus 1y. Similarly, x cube d cube y by dx cube, it will become d minus 1 d minus 2y and so on. So what we have to do, we have to replace x by e raised to z and z by log x, and x dy by dx by dy, x square d square by dx square by d minus 1y, and so on in this equation. So we will get the equation of the form function of dy equals to rz. Then after we will solve that particular differential equation as discussed earlier. So its solution will be y equals to cf plus pi. But cf and pi will be in terms of z, and we will convert z in terms of x with the relationship x equals to e raised to z and z equals to log x. Okay. Also, let's start with some examples. Example number 1. We have to solve this differential equation, that is x square y double dash minus 4x y dash plus 6y equals to 21x raised to minus 4. Now you can see that this is a Cauchy Euler differential equation, because with y dash you have x raised to 1, with y double dash you have x square. Okay, so to solve this type of equation, we will suppose x equals to e raised to z. So taking logarithm both side, we have z equals to log x. Now, as discussed earlier, we have x dy by dx equals to capital dy, where this capital D is d by dz, and x square d square by dx square, that will be d minus 1 y. So replacing x dy by dx, that is xy dash by dy, and x square y double dash or x square d square by dx square by d minus 1 y, and x by e raised to z. So we'll be having d minus 1 y minus this one 4 will be as it is, and xy dash, it will become dy, then after plus 6y equals to 21, and replacing x by e raised to z, so it will become e raised to z the whole raised to minus 4, so it will become e raised to minus 4z. Now we have to simplify this result. D into d square minus 1 into d 1d, this is minus 4d, plus 6y equals to 21 e raised to minus 4z. Now minus 1d and minus 4d, the result is minus 5d. So we have d square minus 5d plus 6y equals to 21 e raised to minus 4z. Now this differential equation is of the form function of dy equals to r of z, and its solution is y equals to cf plus pi. So first of all we will find out cf, that is complementary function. To find cf we equate d square minus 5d plus 6 to 0. Now we have to factorize this equation, okay? Right, we have to split middle term 5d such that the product of two terms is 6 and their addition is 5, that is 2 and 3, okay? So after taking common and simplification you will get two factors, that is d minus 2, d minus 3. Now equating these two factors to 0 we have d equals to 2 and d equals to 3. Now writing CF, that is C1 e raised to 2z plus C2 e raised to 3z. Why? Because now this differential equation is of the form function of dy equals to r of z, and capital D is d by dz. That's why we have to write down z over here, okay? Now e raised to 2z, that is e raised to z the whole square, so e raised to z is x, so it will become c1 x square, okay? Then after plus c2 e raised to z the whole cube, and e raised to z is x, so it will become x cube. So cf is c1 x square plus c2 x cube, okay? Now we will find out pi, and the formula for pi is 1 over function of d into rz. F of d is d square minus 5d plus 6, and rz is 21 e raised to minus 4z. Now this is case number 1, replacing d by e, that is minus 4, so minus 4 square is 16, then after d is minus 4, so minus minus plus 4 5s are 20 plus 6 and 21 e raised to minus 4, and that will be as it is. Now this 21 will be as it is, and total of 16 plus 20 plus 6, that will be 42 into e raised to minus 4z. Now 21 by 42, that is 1 by 2 e raised to minus 4z, and e raised to minus 4z is e raised to z the whole raised to minus 4, so it will become x raised to minus 4 divided by 2. So the general solution is y equals to cf plus pi. Cf is c1 x square plus c2 x cube, okay, that is this one, and pi is x raised to minus 4 by 2, right? So this is the required general solution of given differential equation, okay? Now we will see second example, that is we have to solve this differential equation. Again you can see that with dy by dx we have x raised to 1, with double derivative we have x square. So this is a Cauchy Euler differential equation. Now let x equals to e raised to z, taking logarithm both sides we have z equals to log x, and replacing x dy by dx by capital dy, x square d square y by dx square by d minus 1y, okay, and log x by z. So we have d minus 1y minus dy, then after plus y equals to sine of log x, so replace log x by z, so we have sine z. Now we have to simplify this equation, that is d into d square minus 1 into d 1d minus 1d plus 1y equals to sine z, minus 1d and minus 1d, that is minus 2d. So we have d square minus 2d plus 1y equals to sine z. Now again this differential equation is of the form function of dy equals to rz. So its solution will be given by y equals to cf plus pi, where cf is a complementary function. So first of all we will find out cf. To find cf we have to equate f of d equals to 0, and f of d is d square minus 2d plus 1. So d square minus 2d plus 1 equals to 0. Now applying the formula of a square minus 2ab plus 1 on this function, a is d and b is 1. So we have d minus 1 the whole square equals to 0. Now we have factor d minus 1 two times. So equating d minus 1 to 0, we have d equals to 1 and d equals to 1. So for this one we will write down e raised to 1z, and now this one is repeated, so we will write down z e raised to z. So C1 e raised to z plus C2 into z e raised to z, that will be the required CF. Taking e raised to z common, so in simplified form we have C1 plus C2z into e raised to z. Now C1 will be as it is plus C2 will be as it is, and z is log x and e raised to z is x. Okay. Now we will find out pi. The formula for pi is 1 over f of d rz. Here f of d is d square minus 2d plus 1. Okay, that is this one. And r of z, that is sine z. So we have 1 over d square minus 2d plus 1 sine 1z. Now this problem belongs to case number 2. Value of a is 1 and we have to replace d square by minus 1. If you will replace d square by minus 1, so it will become minus 1. Then after this minus 2d and this plus 1 and sine z will be as it is. Now minus 1 plus 1 will cancel out, so we have minus 1 over 2d sine z. Okay, and 1 upon d, that is nothing but integration, because d is derivative, so 1 upon d is integration. So this minus 1 by 2 will be as it is, an integration of sine z, so that is minus cos z. So minus minus will cancel out and the result is cos z by 2. And we have to replace z by log x, so the pi, that will become cosine of log x by 2. Okay, now the general solution, that is y equals to cf plus pi, and cf is c1 plus c2 log x into x. You can see it from here also. Okay, this is the required cf. And then after pi is cosine of log x by 2, right? So this is the required general solution of given differential equation. Okay, so this was all about Cauchy Euler differential equation. In the next lecture we will see Legendre's differential equation. Done. Thank you for watching this video.